This
session we will
conference
discuss
will
about,
now be recorded.
yeah, thank you very much. And in this session, we'll be discussing about sidecar containers, what is init container, and Kubernetes maintenance, stateful and headless services. So we'll try to cover up these points, 4 points, guys. Okay, so this is basically this two teams have been divided to that is one is CKAD and CKA. So on Saturday, CKAD sessions are going on. On Sunday evening, CK sessions are going on. If I'm not wrong, and I think you are the part of the CK team. So in this, we are going to discuss some of the part called as a sidecar containers, and then we'll go for the further topics. So as we say that pod is a multi-container, right? We can have one pod. We can have one container in one pod, or we can have multiple containers in one pod, and that's why it is called as a multi-container pod. But what is the use of it, and why should we do it, and when, in which condition you should have a multiple containers, and what is the meaning of sidecar containers? We'll see that, guys. So basically, let me just show you one diagram. So what is a multi-container sidecar pattern? This is nothing but something like is the most common pattern for multi-container deployments. Sidecar. There are multiple patterns are there, such as ambassador pattern is there, such as adapter pattern is there, and sidecar pattern is there. It has its own significance. So in your particular segment, that in this session we are going to discuss about only about the sidecar pattern. I'll just give the hint about glimpse about the other patterns too, but mostly we will cover this sidecar pattern only. So let me just open one my doc. Okay, guys, let me just start whiteboard. Okay. So consider this is your pod, and in a pod, you can have a multiple containers. Okay, so this is your pod, and in a pod, you can have a multiple containers like this. This is a container 1, and this is a container 2. You can have multiple containers as well. What is the good thing? Let's say that I have the Nginx image here. Which is my web app. So in which scenario you will require the another container inside the one pod? Do you want to create a replica of this container? No, then it should not be, right. You should not have the, this is a wrong, bad design, guys. If I have a Nginx image, Nginx containers too, so we don't, it should not be a replicas of the containers inside the one pod. Okay, so what is the, then what kind of container we should have, which is another container? So basically it should be supporting container. It should have some algorithm which should be in supporting nature. What is the meaning of supporting in nature? Maybe something like that. You have main application running inside container 1. In container 2, you can keep something called as the secrets. Secrets is nothing but passwords, SSL certificate, TLS certificates, that kind of thing. You can keep it there. Another information that you can pass in the supporting container as, let's say, environmental parameters, config maps. That is also a good example that you can do that when you can keep you can make it as a sidecar container. Another thing that you can for another purpose for which you can create a sidecar container is something like let's say that proxy connections. So there are various applications are there. There are various things that we can do along with this container. Okay. So one container should be your main container, another container should be supporting container. In the microservices pattern, what people do normally, if you have, if this is your, if this is a main container, and if you have a small database related to this application, that they can create small local database here as well for that particular application in the microservices part. So you can have a multiple purposes of the containers, sidecar containers. One container is your main container, which will be doing the major job of kind of heavy lifting work, which will be serving to the customers, which will be doing the business, which will be executing the business logic. However, supporting container will always help you to keep the secrets or make sure that proxy connections are passed through this sidecar container. Okay, so what is the scenario in which we should use the sidecar container? That's what we have discussed. But let me show you a specific condition in which we can create a sidecar container. So I have one example to show you here. Let's say that you have a pod, and inside that pod you have two containers. One is your application container and another one is your sidecar container. Okay, so what this container is going to do, there is a file system. You can say volume, any volume, that can be your mtdir volume or it can be your persistent volume, any volume is there. And what sidecar container will do, it will write the contents inside the file system. And what application container will do, it will pick up the information from the file system container. So you can say this is something called as a writer container, and this is something called as a reader container. So whenever you want to write something or something in the, let's say, file system, that time you will use this container. And whenever we would like to use that contents which has been used by, written in the file system by this application container, so it will read the contents from this file system. So you can segregate the duties of the container space, right? One, you can distribute the load, you can segregate the responsibilities of the containers by doing this kind of things. And the customers will, or consumers or users will access the application content from the outside, exposing the services. This is one of the good example of the sidecar pattern. So let's take one example. Let's say that I have one pod which has two containers, the first container and second container. You can see here. So what we can do in this case, this is my first container, this is my second container, right? So second container is used to write. It has some algorithm which will write the contents inside this particular volume, maybe inside the HTML folder or index.html file. And this volume called as HTML is mapped here. So whatever the data is written by this container is read by this container, and that is accessed by the outside people. So this is a sidecar pattern, guys. So now let me just show you this by example how to do this. Okay, and you can see this is the manifest of this. So how we can declare the pod? It is a similar structure that we use every time. So you can think about that. This is my API version, kind, metadata, and inside the specifications, we have a one volume section, and it is just empty dir, right? This is the volume, and you have given the volume name as HTML. So this is my volume, you can say. Now, then we have two containers. Container first. This is the definition of the container first. which is my this container. This is the second definition of second container, which is this one. Okay. So now what is going to happen here now? This is something Debian image has been used, and volume mount, it is same thing, volume has been used, HTML, and path is /HTML folder, which is inside this second container. And it is writing some algorithm. What is it writing? It is writing saying that while true to date is equal to whatever the date right now is there, it will be redirected to the inside the volume. There is an index.html file will get created, and inside that volume, this the date will be written here. This is what algorithm is. And what your container one will do, this container one will, it is again mounted the same volume, it will start reading the contents from. So this is your first container which has the image nginx, and what is HTML is mounted. So same volume has been mounted here. Where it is mapped or mounted, you can say it is mapped to this particular folder. So it is very simple, guys. This particular second container is writing the data inside the HTML folder index.html, inside the file index.html, and that is read by the container one. So I'm going to show you how this behaves, how the sidecar container sidecar pattern behaves, right? So I'll demonstrate this one so that you will have a clear picture. So before doing this one, how I can write a multi-containers, right? So if you want to create a pod with a multi-container pod, what are the different ways that we can do? That example also we'll see, and as well as we'll see this example so that you can understand it better. So in short, sidecar container is nothing but it is a container which does some responsibility, which have some responsibility, and which acts as a supporting actor to the your main container. Okay. So let me go to the now command prompt and deploy this application. Okay, so I will go to my location called as Kubernetes, and okay. So consider that, guys, I want to write a multi-containers. So how do I do that? So let me open one file, cat mc1.yaml. Okay, now in this one, what I'm going to do, I'm going to just copy something here. Vi multi-container 111.yaml. This is file I'm making, and right click. Now look at this, guys. So this is API version v1, kind is pod. Metadata is written as, let's say, more than one container, right? More than one container. This is the name I am giving to the pod. This is first container, right? We are writing a first container definition, container one. Which image we are using? Nginx, and this is a simple port container, right? Now I want to write another container, create another container inside this pod. So can I copy this photo file and say, as I can copy this file YY, and let me paste it here. And can I have something called as, let's say, image? Let me take a Alpine image here. This is the operating system image, container 2. And since it is operating system, there won't be any application running inside. Okay, so this is a simple container which has the Alpine operating system. Let me create one more container, nothing but name C3 image. Can I use HTTPD? Let me use ports here, and inside that container port, let's say 80, and protocol TCP, let's say that. Okay, so I have three containers. I can write more number of containers also. I can use one more container 2YY and I can put it here, C3 container. So this way we can write many definitions, right? We can write many definitions. Now let me tell you this, will this work, guys? Okay, so let's try out doing that one first of all, rather than saying it, and see what are the problems we are facing here and how we can solve these problems which are coming because of this issue. We are trying to create now how many containers? We are trying to create a 4 containers now inside one pod. Okay, till yesterday I tried 3 containers. Today I'm trying a fourth container. Let's see that what happens. And this time I will use some other operating system, right? Rather than using a C4, let me use Alpine, let me use BusyBox, something like that, right? And let's see what happens now. Save this. Kubectl gate pods. Let me see if there are any pods here running. Oh, so many are there. Let me just delete these guys. Kubectl delete pods db1, I think db2. Okay, I hope that it will get deleted now. All the pods will get deleted. And let me open the one more terminal here. One more thing that might comes in my mind, if you have multiple containers inside one pod, right, how they will talk to each other? Because all the only one IP address is there, and that has been assigned to the pod, you can say. So all in short, all the pods has one IP address only. Then how one container will talk to another container? So if you know the answer of that question, guys, you can put it into the chat box. What feels that how these 2 containers or 4 containers will talk to each other in case they want to talk to each other? So you can put the answer in the please in the chat box if you know that. Kubectl delete. Let me delete the deployment. db1. Okay. Now, yes. So I have just now I have created one file called as mc11. Kubectl apply -f mc11.yaml, and this is what we have created. And most probably what will happen, guys, this is going to fail. Let's see that whether it is failing or not. Watch kubectl gate pods -o wide. Let's see what is happening here. Only one pod, only one container out of 4 containers has started now. All other are failing. Can you see? Only one container is started, all other are failing. Look at this. Restart is 6. So now let us see the describe this one. See what is happening here. Kubectl describe why this is failing 4 containers. What is the problem? All the components are there, everything is fine, but still it is failing. Why is it so? So you can see that it has pulled the image. Nginx successfully pulled the image. It has created the container. So my first container has successfully created. Now you can see that directly it has gone to the BusyBox container 4. Then it was trying to pull the image. Then it has started creating a container C4. C4. It started creating a container. Okay, and then pulling an image BusyBox. So ideally it should have started all the containers, right? But it is not starting it. It is just starting one container. What could be the reason for this one? So let's try to, okay, so let's try to now open the multi-container file MC11. Sorry. Okay. Now look at this, guys. So what should I do so that they will work properly? So first of all, this port numbers are issues because this is Nginx image and this is HTTPD image, and both of them works on the same ports. So this is one of the issue. So you cannot have inside the pod multiple services are running on the same ports, right? So it will create a problem. Then pod will not be able to understand it. So now what we can do now, we'll try to separate the image and we'll change the image called as HTTPD from this one. So what I will do, I have another definition which I will try to show you, cat mc1.yaml. Okay, so what I'm going to do, I'm going to use this image PHP Apache. So instead of HTTPD, we'll use this one. And we can use here port number 8080. Probably it works on the 8080 port. And rest of the things are same. Okay, it is 8080 only, right? Now, so now we'll try to deploy this one because we have segregated the ports here, 80 port, 8080 port, and this is my just operating system container. This is my PC box container. Now, so just to avoid this issue, let me try with the another container here that is called as Ubuntu. Just I'm trying to download the Ubuntu container, create a Ubuntu container. So, and I need to change now this one pod name, otherwise this is more than one container one. This is the name I'm giving. kubectl apply -f mc11.yaml, and moment I now check it, can you see now it is trying to create a containers, 4 containers. Till now none of them is started now. Once this exercise gets completed, so that you will understand how to start the multiple containers in one pod, and then we'll go for the sidecar container example of the sidecar container, where I will show you that one container is a web app container and another container is a just a normal container which will try to write the data inside the volume, and web app container will try to read the content data from that one. So this is also, guys, it is creating a problem. See, it is only showing that 1 out of 4 is ready and all of them are now crashed. So same issue has happened here as well. So what should I do now? What I will do here now to solve this matter, I will add some delay inside this after every container. So to add the delay, I will use this command. Okay, and now let me try to do that. MC11. So to start the another container, there should be some delay, or there should be some command should run, right, in container, then only it will work. So container always requires some command to run, and this is what I'm giving. After this one, here also I'm passing the same parameters, and after this also I'm giving the same parameters. Okay, so all right, I think this is now looks a little bit better than the earlier script. Let me use more than one container script. So let me make it 2. So this will be my another pod will get created. But here now I have added the command in every container. Now let's see that what happens. kubectl apply -f mc11.yaml. It has created. Let's watch it for some time. So now container 2 is now it is showing that 3 containers have started. Now one container is still failed, right? So I think I need to add command in that container also, then only it will start running. So now I have success that earlier there was one container was failing. Now it is 3 containers are starting and only one container is failed. So let me put one more command here. Okay guys, and I think this should work now. Let me save this and apply. Okay, and let's watch this. So now it is creating a container. It should create a 4 containers now. Let's see what happens. It is working on the worker 1. This has gone to the worker 2. Now it will download all the images. Yes, and now you can see that all the containers are started running. So what is the observation here, guys? The first thing is that the port numbers. Second observation is that we should have some different type of the, let's say we should have something called as a commands there. We should interrupt, we should give some commands inside the container so that while creating it, it will just wait there, it will have, and it will be in the running process, and then another container will start running. Otherwise, if at all you are trying to start all the 4 containers together, it may create a problem. So let's give some delay there, or maybe let first container get started, then start the second container, then start the third container. That way, if you do that, it will be better. So now my 4 containers are running. This way I can add multiple hundreds of containers, guys, in one pod. Let's describe this one, kubectl get pods, and I would like to describe this so to make you understand what has happened actually. Yes, and now you can see here, guys. It has started container. Now it is started in the sequence, guys. If you see here properly, first of all, it has started C1 container, started C1, created C2 container, then started C2, C3, C3, and then C4. So now this is working fine. All right. I hope that now you have understood how to create a multi-container pod. But how to log in inside this? If I have 4 pods, how I can log in? So you can see here there are 4 containers running now, right, guys? C1 container, C2. These are the name of my containers. C3 container, and this is a C4 container. So where is my C4 container? Yeah, this is C4 container, and all of them are running now. So how to log in inside each container? So to log in inside each container, you can use docker kubectl get pods, right? So this is the name of the pod, kubectl execute -it. This is my pod. The container and name of the container is important here. So now this will log in into the first container, and it is something called as, it has some I think website. It is an Nginx image, and you should be able to access it. Okay, is it a user share Nginx cd html? It has a data. Okay, no problem, guys. Let's move ahead and see another container. How to log into the second container, container 2. Oh, this is my, I think, Alpine, so it should be sh. Okay, so it is working fine, guys. You can see etc os-release. So this is my second container, started perfectly. Third container is my C3. Okay, this is PHP or something like that. Let me just check out PHP version. And you should be able to see the PHP version inside this. Yes, it is there. And I have a fourth container, which is my Ubuntu container. And you can see here cat etc os-release, and you should be able to see Ubuntu. Okay, so this is a Ubuntu image. All right, guys. So these are the 4 containers created. So now, before going to the sidecar container, let me see if you have any questions.
Ramesh, one small doubt. Without providing -c with the name of the container, is it possible to log into container?
You can use a Docker command.
No, I'm talking about a kubectl command only.
As per my knowledge, I know this command. Any other command, I have to check. But this is the command I am frequently using. Otherwise, I go to the worker nodes and Docker command. If you know that one, let me know.
No, I don't know. Actually, interviewer asked me the question.
Huh?
Interviewer asked me the question.
Understood. So that question might be something like this one. Can you see the contents of the container without logging inside it, or is there any?
No, the thing is, in command you have used -c, right? Login into a container, right?
Correct.
He is asking without using this -c, can you able to log into the container? Me the question.
No, we will be able to log in, but it will take to the first container only. I can do that. See, if I type here without -c, and if I put here bash, it will take. Let me use. Yeah, I'm inside that. Okay, let me just go there. Exit. Let me exit from this place. Yeah, I'm inside the container 3, right? So look at this.
Yeah.
I'm inside the container. This is my actually host, right? So without -c, we can log in, but it will take a default one, first container.
Okay. Okay, thank you.
That is what I feel. Okay. So they normally interviews will check the confidence, that right? That is only one thing they always do. Okay, cool. Can I have the mount path? Padmashri is asking, can I have the mount path for both containers as same, which can be either HTML? That is possible. That is possible. That we can do.
Okay, thank you, Ramesh. Yeah, it was mentioned in the example, so I was just curious why there are 2 different paths. Thank you.
Right, we can do that. But there should be some meaning for that.
It's like a best practice, right? I don't have to remember 2 different paths, like the read and the write. If they are in the same path, it's easy for me to design things. So rather than having 2 different paths.
Okay, I got it.
Yep.
Yeah, good. Thank you. Abhiram, yeah, you pointed out rightly. Both container code can be same. That is a question you have asked, right?
Yeah. So Ramesh, one thing. So this sidecar pattern, I kind of joined it, but a sidecar pattern can be at a container level only, or if I want to implement and design, can we go beyond that, or is just that at a side container level, or?
It is a pod level component. It is inside the pod.
Correct. So like sidecar, what I was thinking is a daemon and all this, right? Logging and all. So that can be at the namespace or that level also, right? Or how? I mean, that's where I was confused. Are you getting that point?
It is a namespace level.
Oh, okay. So it is at a namespace. So okay, overall it is at our namespace level. Okay, got it.
Yeah, overall it is at the namespace level.
Okay.
Any pod itself is a namespace level component.
Oh yeah, correct. Makes sense. Yeah. Okay.
They have a different codes. Yeah, the Padmashri we changed it, right? Port number, please. Bridge network. No, in the same pod, you don't have to use a bridge network. It will use the same, because it is the same IP address. So all the IP addresses, all the containers will be using a local host 127.0.0.1 IP address. And only difference will be there. The application should be running on the different port, or it should have a different function. Otherwise, there is no point in having a multiple containers inside one pod. Okay, what is a Partha is asking? Within a pod container, talk to each other using the same IP, so the ports cannot be shared. Yeah, it is using a 127 IP address, right? Huh? I think Partha, it is clear, right?
Yeah.
Okay. No, Ramesh, it will communicate via IPC namespace. Since they share the same namespace. No, it is inside the pods. I hope that it is related to the same thing, right? Ramesh, you have written this one. How the containers will talk to each other.
Yeah.
Okay. I hope that you got it now, right? Okay.
Yeah.
Pujita, yeah, thank you. Pujita, in the starting only I explained it, but let me tell you that sidecar containers are the containers you can use for as a supporting container where you can keep the environmental parameters. If you want to supply the secrets such as SSL certificate, TLS certificate, rather than keeping inside the application container, you can keep it at the another container and you can ask the traffic to shift it from that one. That is also possible. But that is called as it is a different pattern, container pattern. But whenever you want to use any container as a sidecar container, it should not be it should be a supporting, like it should not be heavy lifting activity doing. Heavy lifting activity will be done by the main container. So examples are like environmental parameters. There are adapters are there. Then there are a lot of you can say if you know about the Istio can also create a lot of sidecar containers for injecting the different configurations or taking the lot of monitoring parameters from the containers to the at the central portal. That time also we can use the sidecar containers. Is that make some sense, Puchita? Is it clear now? Akhil is asking, yeah. Initially, you have not given the command in all four, but still one container is up. Why? Because only first container got started, right? And it was having some command. Second, Nginx was having only command because it required some HTTP or Apache services starts. But in any other this one there was no this one, and because of that it was failing. So please keep this in mind. If you want to start any container, some process, at least one process should be running inside the container. Otherwise, your container will fail. Right, Akhil? Murli is saying, how do you come to conclusion that adding sleep time on command before adding them inside the YAML file means how do I find the issue of the YAML file? Murli, you might be thinking that after adding the commands, it has started working, right? Yes, correct. The Alpine image requires some command. I need to start some process inside that one. Then
Yeah,
only it will work. Yeah.
yeah, but how do I debug, Ramesh? But so if the first
You
issue
have to
is
check.
the port, right?
Hmm.
Yeah, but somewhere it shows that address is already in use, and second case some kind of issue. It has to tell us, right?
Right.
So
It will definitely tell you. You can use the events. You can check the logs. It will definitely help you. See, you can. It is saying back off, right? Fail, back off, restarting, fail, continue. There will be some logs will be there which we need to monitor here, and uh, this will help you to find out information. No,
Or
this is starting from.
general practice to add a delay.
Yeah, it is. No, it is not a delay actually. It is a command. So rather, while creating a Docker file, if I write some command inside the Docker file and ask it to start, it will not fail.
No,
I
but
think you have added a delay, right? Can you show us the YAML file
60
one more
minutes.
time?
What does 60?
It is a delay of 60 minutes, but it is a command which is executed. You can see here now. Let me just show you. It is a command basically. It will keep the container running for 60 minutes. I have used 60 minutes. Okay, let me just go there. Now, this is a command actually, and asking the container to sleep for 60 minutes. So this will run in the this command will run in the RAM, and that's why it will hold the container for that many minutes. So in production, this command will not work. After 60 minutes, your container will be down.
Yeah, that was my next question then.
Yeah, it will be down. So make
then,
sure that we have to write such a logic that your container, the process will be running continuously in the RAM of the container, so that container will be running. You have to use some other commands. Is that fine? Okay. So I was trying to explain the answer of the question of Akhil, if I'm not wrong. Akhil or somebody, Murli was there, right? I
Yes,
forgot
sir.
whose question. Yeah, it's Murli, right? So Murli was asking that how we can find out the log. So Murli, I will be will try to explain you the logs which are about the. There are logs inside the syslog also. That comes into the application maintenance work. I have that complete session for that. I
Okay.
can check in the syslog as well. Here you can also find out what are the issues going on related to pods and everything. Right. So this we'll see in detail if you don't mind. Okay.
So, so
So
by default, it goes to the syslog, all the pod logs.
this is operating system level. Na? So kubelet related logs, if there is an issue with the kubelet or if there is an issue with the daemons which are related to the Kubernetes cluster, all that logs can come onto the operating system host level. But don't worry guys, I will explain you this. Okay.
Okay.
Otherwise,
Yeah.
this will get
Yeah.
diverted to something else. Now the
Yeah.
main
But
yeah.
yeah, Ramesh. But for debugging part of while creating the pod, that is important. So we
Yes,
should
yes.
know why it is not creating.
I will definitely show you that. Definitely. Don't worry.
Okay. Thank you.
Yeah. If I don't show you, remind
Yeah,
me.
Ramesh.
Don't worry. Yeah, go ahead.
Yeah. So, Dakil, actually, my internet connection was lost, and I think my question happened. So, uh,
No,
in the beginning, like you have not mentioned commands in the four containers, right? I mean, the process, like sleep commands.
correct,
That
correct. Huh?
time, like one container out of the four started. So, and in the other example, you have given a command in the three of the containers, and you missed the one in the fourth.
Correct. And it didn't work proper.
Yeah, like if nothing is given, how one container worked and
Actually, the first container was Nginx container, right, Akhil? And Nginx
like,
container. See, I use one word, one sentence. I think your internet was lost. But let me tell you again this one. Let me recap this for you. If if you want to run the container continuously, one process should definitely get started inside the container. Then only it will be in the position of running. Otherwise, it will stop or it will get exited. Okay, so when
okay,
when there were I wrote the four containers, but out of that only one container got started because Nginx has one daemon which which gets started when you start the container. That is nothing but some HTTPD daemon gets started, and that's why it came up. But all other three were not running properly because there was no command running inside it, so they were just exiting. Okay. So please keep this in mind that if you want to run the container continuously, at least one process should be running inside. That is one thing that you need to remember. So I can use
Thanks,
any yeah, thank you. All right. I hope that Murli I have explained your question. And Anirban, will the similar ports used by the multiple container is the reason for the failure of pod setup? Yes, it can be, because you have only one IP address for the pod, and anyhow, and you have a local host IP address called as 127. So if you have one LAN card or one IP address, then for that it will have only one service will be running on one port. If you have multiple services running on same port, that is not the possible. It will fail for sure.
Okay, Ramesh, got it.
Yeah. Okay. So logs will be seen. That you can use event, you can use describe. We have a Docker logs are there. We have a Kubernetes logs are there. We have system logs are there that we need to monitor, and the location of the logs, how to check it, and what is the meaning of each log. I will definitely explain you guys. Right? Don't worry about it. Now,
Ramesh,
yes. Any
I
other
have a
question?
question. So, yeah, in status we say crash loopback something, right? For the
Crash loopback comes even though your image is downloaded, right? Image is
okay,
downloaded to the specific worker node. Still, you can get the crash loopback error. So when this is happen, this can happen when any process is not started. Second thing is that in case ports are wrong. Third thing is that in case you have not provided the environmental parameters which are required to start the containers. So if the conditions are not fulfilled, then only your container may go into the crash loopback error.
okay, got it.
Another error comes is that if you start the container with if your container requires root ID, but you are trying to start the container with the normal user ID, that time also your container may go into crash loopback mode.
Okay, there is one more thing. See, we understand the concept of this sidecar container. Okay, we can consider this as a supporting container. Okay, so why can't we go directly to the volume and which is been mapped to the original container or the main container? Okay, which is going to take all the load. Okay, and then that will also populate that
See,
data in the
basically,
main container, right? Is it
what is
because of
yeah, go ahead, complete your
So
question.
is it because of the same reason, the secrets, environment parameters, and proxy connections? I mean, we can't because it is some kind of the data which has to be there in a wallet kind of thing, and that's the reason
No, that is one
why
of
we
the
can't
reason for
publish it or write it.
that is one
Mhm,
of the reason for sure.
mhm.
But another important reason for that is, try to understand. Sorry. Let's say this is your important pod. This is your important container. This is container one, and you have a sidecar container called as a container two. What is the your job of the main container to perform the business logics,
Yeah.
right? Now you are saying that what will happen if you directly map the volume or directly map the configuration parameters to it? What will happen? What will happen? I'll tell you one thing. If I try to modify something, let's say I have mapped some parameters here, or I have mapped the config maps here or volumes here, right? By the way, okay, but due to some reason I want to change some parameters. I want to add SSL certificate. Okay, so if I want to add these parameters, what I need to do, that I need to rebuild the container again. Okay.
Okay.
So why should I disturb my main application? Rather than that, what I will do, these dynamic parameters which may need to change anytime, I will create inside this container too, and from this I will inject it here.
So while injecting, if you follow this process for making changes in the parent container or C1, okay, it is not going to ask you for reboot or
No, right.
recreate or
Unless,
something like
right, because I am mapping the same, see, we are, while creating a container itself, we are writing a design or we are writing a logic in a such a way that if something has to be changed from the sidecar container, you don't have to rebuild the container. Okay, so you
that.
can do
Okay,
that one.
okay.
This is actually the job of the service mesh architecture. In the service mesh architecture, you will find the sidecar containers only.
So the sidecar container can be example of a config map volume.
Yes, it can be a config map volume. Yes, correct. It can.
Where we don't have to refresh the container C1 main.
Right. That can be one of the example. Yes. So your main container will not get, your main container's business logic will run as it is. You don't want to load the container one. Okay, and let other container do the job of adding some other parameters. Or so another thing is that you don't want to keep the logs on the container one. You want to ship the logs to the container two. That is also possible. You don't want to keep the important files somewhere here. You can put it here. Any purpose you can use the side container.
Yeah. Can you give few examples which, I mean, as you said just now that, by modifying few parameters or environment settings in container C1, you may have to restart or rebuild the container. Okay. So if you do that manually rather than doing the same activity through a sidecar container. So what are those environment settings which we can embed using C2, not directly?
No, see, this can be operating system parameters such as maximum processes, maximum open files.
Okay.
Okay, these are the couple of them. Another parameter is that, as I said, that secrets. Secrets are stored inside the in the container in the something called as etc/pki. That location, these secrets or certificates are there. What I will do, I will keep the secrets inside the C2 container. Okay, and I will map that folder inside the C1 container. Now, if tomorrow I don't want to, I want to use a higher level encryption software, I will just upload in the C2 container, and already that folder is mapped inside the C1. C1 will not need to be rebuilt. You don't have to rebuild this container. So your application will run as it is. You are not touching it.
Yeah. I was just trying to understand what C2 is doing. Okay. I mean, the process of updating C1, okay, what we are not able to do and which requires a restart. I mean, is there some program or is there a different path which is updating?
No, I'll tell you one example.
Which
One
we
more
can
example.
do, man.
Yeah. No, the problem is that if you have thousands of containers running in one, this is one application or one container or one pod is there. That's why you are saying. But think about thousands of containers are there, and you want to monitor these 1,000 containers. How do we do that? Are you going to maintain are you going to log in inside every container and check out the data? No. What we'll do, we'll create some sidecar containers where you will capture the logs, and then that logs will be pushed to some other databases, and from that it will be given to the dashboards. So your main application doesn't get this one. Okay, another thing is that you want to deploy the ingress controller, or you want to change the load balancer, right? In that case, what we can do, you can just uh, put up here some sidecar containers here, right? Like this one. So that, and whatever the information you want to push here, you push inside this one. And this is mapped inside the container one. So you are, rather than directly injecting something inside the running container, it is always better to run in some other container and then push it inside the main container. So you can see the sidecar container supporting actors where you don't have to access the container continuously, a main container continuously. You can make modification to another container and you can push the data, or you can use that data inside the main container. I hope that is clear.
Yeah.
Hey Ramesh, this is just example of just like loose coupling, so that there is a dependency is less dependency, and it's like not loose coupled, right? So that your variables and your configurations on different containers, and so that you can use it later on, so that there is no hard link, or what would say, right? Something.
Yeah, right. It kind of a soft link kind of thing you will be creating inside another container, so that whenever you want to change the parameters in the container too, you can change it. It is a dynamic nature. I will show you one example, guys. We have a very simple example, but very powerful example. I think that will make the idea clear. Is that clear? Okay, but your point is correct, Vivek. It is kind of a loosely coupled structure. Yes, Surendra. Supporting container, can I have one container to multiple business logic containers, or else each business logic container need to? If they are in the same pod, normally we don't go for the more than 2 containers inside the one pod. Okay, and it is not good idea to have the multiple business logics, different containers inside one pod. You will have a different pods for that. And for each pod, you can have a supporting container. I can create one image. Okay, and from that I can create a multiple supporting container that can be called inside the multiple pods. Right, Surinder?
Yeah, got it, Ramesh.
No, volume is a persistent volume, Padmashri, here in this case. If it is something like your volatile or non-persistent volume, then it is going to be cleaned up once your container is done. See, number of containers can be there. As I just shown you that we have just gone with the 3 containers. I can create hundreds of containers, but it will create a problem, right? So having a multiple containers is not going to solve our purpose. So you can create multiple. There is no limitation as such. Arun.
Ramesh, just one question related to Padmashri. Like telling it's loosely coupled, but like if you are doing some modification in C2 and C1 needs to fetch some sort of a parameter. Okay. So when we are making some changes, we are upgrading C2. That time C2 will not be available, right? And if C1 want to fetch some data from C2, at that time this container will not work, right?
So actually, what will happen? I'll tell you what will happen. If you have the 2 containers, one is the sidecar container and the one is the main container. What will be the status of the pod if one container is died?
It will be in suspended, means like
it will not work.
Yeah.
Are you getting it? And that is
Correct.
why we have a replicas of it.
No, got it.
Okay.
So it's advisable to have for a sidecar container, like we should have a replica. It's not only for a main container, but yes, for all. So because replica is on the pod, yeah.
We will never deploy an application without deployment. Yeah, without deployment. Single pod is not good.
Ramesh, the sidecar container is down does not mean that main will go out, right? I mean, sidecar could be anything, right?
No. It is a container altogether. What will be the status of the container pod if there are, you see, right? We did that one. Out of 3 containers, 4 containers, only 1 container was up, and other 3 containers were down. But what was the status of the entire pod? It was a crash loop back.
Okay. But one container was running. Yeah, I mean that's my point. Was one container is kind of running status, but overall pod status was okay. Got it.
Pod status was down, so that service will remove the entry point of the pod, which is in the crash loop back or in some other status. Right.
Okay.
So that will not serve the request of the customers.
Oh yeah, makes sense. Okay.
Yeah, Arun, I hope that you got the answer of the question now.
Yeah, okay. Thank you.
Yeah. You are saying that sidecar container is removed altogether. That means you are changing the manifest of the pod. So when you are changing the manifest of the pod, actually that means you are creating a new pod itself. Okay, cool. Okay, let me immediately just deploy this one application which is there, which we are supposed to do. Let's see, what is the name of that application? Create a multi-container pod, right? So we have a multi-container.yaml. So let's do that. Vi multi-container.yaml, and look at this, guys. This is the same YAML file, manifest file, which is nothing but many sidecar. This is the name I have given. We have first container, we have a second container here, and the volume which is there is whose name is HTML. It is using a temporary. It is the imperial volume we are using. Okay, and now what is happening in the container 2? Container 2 is doing a job of writing, and container 1 is doing a job of reading, as per our diagram, right? As per our earlier discussion, guys. This one. This is my container 1, which is a reader, and this container 2 is writing. Is writing the data inside it. So now look at carefully. First of all, second container, then go for the first container. Right? So now, and here also see, guys, there is no command here written in the first container. Why is it so? Because Nginx has itself one process running inside that. But look at this. This Debian command, this will not run if I remove this one. If I remove this one, it will fail. So that time this will be useful. So what you are asking to container do? Write a date inside the index.html and sleep for 1 second. So this will go into the infinite loop, right? So it will just keeping writing inside that. Okay, and this is mapped. Where it is mapped, this is a HTML folder, mount path. In which operating system? Debian. In the Debian container, you have a /HTML folder, and that /HTML folder is mapped with what? This empty directory. Correct? And so whatever you are writing inside the HTML folder, it is writing inside index.html, and this particular file is mapped where? It is there on this empty dir, and this empty dir is again mapped where? It is mapped to the container 1 first containers user share nginx HTML. So actually index.html file is inside this one.
So Ramesh, in your previous example, if you have used Nginx image for all the 4 containers, then that would have run.
No, that is again a problem. How I can run multiple Nginx images on with the same port number? I need to change the port numbers then.
Yeah, if you change the port number, will it work?
Then that image will be different then. It will not be the same image.
Okay.
Ramesh, the volume name HTML empty directory, where that was created, it's out of the pod or it's in the pod?
It is inside the memory space of the container.
Inside the memory space of a container, or it's in a pod?
No, pod is just logical space. There is nothing for the pod.
Oh, okay.
Everything is the container. Yeah.
Okay.
Okay. Let me save this and deploy it, guys. kubectl apply -f multi-container.yaml. I hope that this will work, guys. kubectl get pods -o wide. And this many side container is started. What is the meaning of this now? 2/2. Is it a pod or is it a containers?
Container.
Containers, right?
Containers.
Okay. Because I am using a pod here, and if I use the deployment, then what will be the meaning of the 2/2? Pods, right? Number of pods. Now, kubectl describe you can check out this guys get events also here. Now just now I have deployed this one. You see what it is showing. It has not yet come. And let me do the deployment. This will describe also. Kubectl get pods. Kubectl describe pod my side container, and you will have these two containers inside that. You can see this, there are two containers here. And which command is running inside this in the second container? You see, this is the command running in this container. This one. These are the arguments passed. So everything is given. And what is the mount point? That also is available here. HTML. Okay, now. And here also you can see in the container one, it is user share nginx HTML from the HTML has been mapped. Now let's verify. How to verify? So you can go to the one pod, first pod. Let me go inside the first pod and try to see, yeah, index.html. Kubectl get pods hyphen -o. Okay, so I will go inside the first container because the first container has my index.html. First of all, I'll show you that, and then we will see the second container also. So kubectl execute hyphen -it. The container name should be known, right? What is the name of the container first? Now I am inside the container called as a first container, and inside that cd where no, it is inside user share nginx HTML. You can see here, guys. There is a index.html file, and now let me show you tail-10f index.html. So there should be continuous updates. See, look at this. So your first container is continuously reading the information from the HTML folder of the first container. Okay. Now let me go to the my second container. So now let me go to the second container. I hope this is a name. Yes. Now empty directory is mapped to the HTML folder. Yes or no, guys? It is mapped to the HTML folder. Second container. Your volume dir HTML has been mapped to the HTML folder. So inside this one, you will get a index.html file. And the algorithm which you have written will give you the continuous this output index.html. See, it is continuously writing. So whatever there is in the index.html file which you saw in the container one is the same index.html file which you have saw in which you seeing in the container. So same data is getting reflected inside that container one. So what is the advantage of this one? So if I want to feed some information to my application, continuously some data I want to feed. So let's say I am doing some web scraping of the Amazon website. So continuous data will be put inside this sidecar container. My main business application logic will pick up the data from that and it will display to the customers. I hope that this is now clear to all of you.
Ramesh, can you open the YAML file once again? I have a question.
You want to see the YAML file?
Yeah.
Huh.
Yeah, means here you mentioned that the volume in at the beginning of the spec that the volume name is HTML, and inside the first container there is a volume mounts name HTML, and also in the second container it's same name. So means is there any relation between these three?
Yeah, both. All of them are same.
Okay.
So I can create here anything. I can create a host path also. I can create a persistent volume also, PVC also here, rather than using a MTDIR.
Okay, but the name
What?
should be same to means to map the same file.
Yes,
I
this
think.
is my container one. This is my container two, right? And the data is there. Index.html file is here in the some folder called as /html.
Okay.
Okay, so container two is writing a data inside this HTML folder index.html, and this is reading from this one. But this HTML folder itself, where is this HTML folder? It is there inside, or where is this data? It is in the MTDIR. So this is in the memory. So
Okay.
instead of this, I can use any folder.
Okay, and that is mapped with the mount point of first container, that is the user's shared nginx HTML, and for the second container it will be only /HTML.
Absolutely correct. Absolutely.
Okay. Okay.
All right, guys. Cool. Now this is something about the what is the question? What is the purpose of MTDIR? Arun, I think I have answered your question, right? If I'm not wrong. What is the purpose of MTDIR? MTDIR is the nothing but it is a we have seen in the Kubernetes volume section. MTDIR is nothing but it is a space which is a volatile space which is taken from the uh, RAM of the container. Okay, it is inside the RAM /proc somewhere.
Hey, Vivek, the site, Ramesh.
Yeah, you can go ahead.
So my question is that I understand that within a pod we have multiple containers, but in normal scenario we don't create a pod, right? We create a pod deployment, a pod using deployment, and you have multiple pods basically, right? And in that case, don't you think that the sidecar container, or rather I should say a pod, where we have a sidecar container, and that sidecar container oblique pod, whatever is it, supports your multiple deployment, or maybe a deployment instead of supporting a single pod or single
Correct.
container within that pod.
Yeah, so I think your question is like that, how it will be, because there is some are you able to hear me, guys?
Yeah.
Yeah, Ramesh.
Yeah.
Yes.
No, what
Yeah.
I'm saying is
Sometimes it gets muted for me. I don't know, maybe my laptop problem or something.
Okay. Yeah, Vivek, I got there was some little bit disturbance. I was not able to understand complete statement. So can you just please repeat if you don't mind?
yes,
Vivek.
I can repeat. My simple is that we normally create the pods using deployment, right? There is no the way a manual process that pod is created by the command line. It is possible, but we are not, as a best practice, we always use deployment. In that case, we have multiple pods, right? In that case, each pod, which is maybe a worker one, worker two, doesn't matter, and we are not static definition of pods. Within the pods, we have multiple containers. That's fine, but just for deployment purposes, how we can support that deployment with the config map. We have an environment variable and config map on a separate pod, but that may be a part of deployment. And then you have actual application running in that deployment, so that instead of creating multiple containers within a pod, we have one pod, one container, that kind of structure, right? And but that container and one pod which has a sidecar container is not within the same pod. It is a separate pod, and that pod is supporting all the pods within the deployment.
No, basically, you are saying that can you create a sidecar pod, right? Sidecar container pod which will have only
Correct. Sidecar
container.
container. Correct.
No, that is also possible. That is also possible. That means you are saying this is my pod. I think this logic is also used. You have a multiple pods here, but they are the replicas. This is the business logic one, right? This is business logic one container, business logic one container, and you have multiple pods here, right? Using the same containers. So this is your pod, and it's a P1. This is your P2 pod, and they are inside the one deployment, right? This is your deployment.
Yeah, that is correct.
Correct.
Right.
And what you are saying
Now
that
we
in the
create.
sidecar container here.
Correct. So that there is a like if we have multiple containers within a pod, that means it's not a microservice, it's a monolithic service, right? So we just need to follow the best practices for where one pod contains one container, and we also have a dependency container which is on a separate pod.
So what will happen here in that case, Vivek? You have to create this is my deployment 1, and this will be my deployment 2.
Right.
Because,
so that deployment 2 will not going to affect anything. If deployment 1 is down, still your deployment 2 is still up and running, and that can be used for your multiple purpose later.
yes. No, this idea is good, but we have to check the scenario as well where we can use this one. Okay.
Why I'm saying is this: if your pod is down, your sidecar container is also down. So there's a hard coupled, right? We need to make sure that everything is loose coupled. So your variable pods are different, and if at the time of disaster or something happened to my deployment, my pod, if it's a static pod, my sidecar container is still up and running. That's why I'm thinking.
So one question here. So are you telling that the volume created by D2 deployment 2 also will be available to D1?
No, see what will happen. No, see this deployment will have a service. You have to expose this deployment as a service, and then you have to call from this service. You cannot directly call here. You cannot call this pod inside this pod directly. We have to go through the services.
Do have to have cluster service. We need to create a cluster service. That's fine.
Yeah. No, this is a good idea what you are discussing right now, but I'm just thinking about what will be impact of this one on the running pods in case this pod is down. Will be the same? Let's say this is, let's say I have this one pod, and inside that I have two containers, container 1 and container 2, right? And if this container goes down, my pod is going down, right? But if I have another pod and there is one container inside this one, this is my S1 sidecar container, and if I'm mapping, if the data of this particular container has been fetched by this container here, okay, and if because of this container is down, if this container is down, what will happen to this container?
There is no HA.
Yeah, will it behave like the same way if this container fails, then entire pod goes down? Will it behave the same way if this container is down and it is not getting some of the functions which are written inside this container is not available inside the container for another. Okay, so there is a possibility that this container may not go down, this pod may not go down, but functionally it may go down.
It might be in the pending or like.
But
there is a possibility. Functionally
Ramesh,
it may go down. Yeah.
What I'm thinking is, it all depends on what environment settings or what all parameter settings you have in sidecar container. If there is a complete dependency, okay, for C1 to up and running, okay, so which always reads the data from S1, okay, and it badly needs S1 to for up and running, then it will go down. Otherwise, no.
Right, correct. I think, but methodology is this is another approach what Vivek has suggested, and I think It is a good approach. I will definitely write some code on this one, guys. I will try in my lab how to set up this one. Okay. Thank you very much for that input, guys. Thank you.
But see, Ramesh, one thing that the case one, the one which where the pod is a different, loosely coupled. If it is a logging sidecar, it will work. The main pod will, because without logging it will work. But if it's something to do with volume mapping, then it will have impact. So that it's could be a case to case basis, right? I mean, that way I can think of, correct?
Right. That means if this is your main container, container one, and this is your another container, sidecar container one, and if you are pushing the data from this to this one, then it may not have an impact. But if you are pulling the data from this one and which is having some important information inside this one, so this will have a definitely impact on this container one. So it is a case to case basis. You are, as you are saying. Correct.
Okay.
Thank you, guys. I hope that everybody has got this point clear now. What is a sidecar container, right?
However, like we are going out of concept, right? Because the whole idea of multi-container is like being in single pod. So
no, what I was trying to think on this one, Akhil, your point is correct. We are going out of this one particular discussion, but one thing is coming in my mind that when I write a script for ingress controller or egress controller, or if I try to inject something inside the container through the Istio proxy, right container, that time these sidecar containers are actually sitting as a different pods. They are not in the same container. I was back of my mind that when Vivek asked this question, I was thinking about it. Okay, so that's why I took some time out of it. Okay.
Got it.
Thank you. So now
one more thing. You know the Gluster service?
Gluster service, I know. Yeah.
Yeah. So how this Gluster service can be used inside the sidecar pattern where you have the volume, and when it comes up, it will be creating and it can be used.
Arun, you need to wait till the dynamic provision concept, persistent volume.
Okay. Okay.
Yeah, and inside
Yeah,
that
I understand. Thank you. It is complex. Yeah.
Okay, thank you.
Ramesh, I have one more question. So, is one sidecar container can it be used, okay, for multiple containers or pods?
No, then it becomes a different. That is what the Vivek was asking the question, right? If I have a container which is inside another pod, can I call it to the some other pod as a supporting container? That is what the whole piece of discussion was.
But then if all the containers, although they are hosting on different pods, if they are supporting the same configuration or same application, okay, then the concept is different. If my application itself is different or customer itself is different, okay, I mean, if I have two different customers, okay, and they are having 10 containers in two different pods.
That is possible. That is possible, Sumanta. That is possible.
Okay. Okay.
That is possible. Yeah.
Thank you.
Okay. Okay, thank you. And Ramesh is asking what is a Gluster service? Gluster is another type of storage, external storage, right? So how you can map that to the container? That is what his question was, Ramesh. Like EBS volume or GCA, you have Google volume or you have IBM.
Okay, got it.
Okay.
Thank
you. Good. Guys, now
the whole discussion just we have completed before, but it is very interesting. But we need to know the result behind that, because how we can implement that means calling a sidecar container from multiple pods.
No. See, sidecar container discussion is completed, and I try to explain that in the pod concept, right, Anirban?
Yes.
What was the discussion? Which discussion was that if I have this pod, inside this pod I have one very important application. This is my business application running inside this container one. So what was the question that if I have another pod and inside that there is a container 2, which is my sidecar container. So this is my pod and this is my another pod. This is my main application. This is my sidecar container, which is residing in the another pod. We can call the services from the another pod also, but for that purpose, we have to use this as a, we have to expose this pod as a service, and we have to call this service inside this pod. So that is possible. We have discussed about this, Anirban. We have to expose this pod also as a service here. And then I need to call the cluster IP address of this particular pod inside the business logic of this container.
Okay. 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 Got it. But
Correct, na?
yeah, yeah. It's means the logic. I able to understand the logic, but the implementation is
Oh,
like,
implementation. For implementation purpose, then I need to go back to the created deployments, two types of the deployments. Now, take this exercise, Anirban, now.
yeah, yeah. Okay.
And please do this exercise. Do you remember that I had created one front-end container called as a PHP and
Yeah, yeah,
backend container as database, and
yeah,
I have linked it, right? Connection, I have done it.
yeah.
Now transfer this particular PHP container as your deployment, transfer this database container as a deployment, and try to connect them. Now think about this is my sidecar container.
Okay, 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 okay. Got it.
Okay. Take an exercise, guys. Everyone, please, when you come for the next session, I request all of you to create a one PHP as a front-end pod container and expose that as a pod. In the deployment, you should have a deployment here. This is deployment, and this is also deployment, and try to connect them. See how it works. I think you should do this exercise, guys, all of you. If you do this exercise, you will understand each and every bit of the deployment then. So if you do that way, Anirban, our sidecar container calling will be done. Okay, thank you. Yes, yes, expose. Correct, Arun. Now we have to discuss about the init containers. This is something interesting. This is also sidecar container, but has a very, very powerful impact. Okay, so in one liner, what is the use of the init container? So guys, consider this is my pod. This is my pod. And inside the pod, I have two containers here. This is my business container, which has a business logic. And another container is called as an init container. Okay, so what is this business container? B1, what is this init container? Please understand one statement clearly and remember this forever. Unless and until init container is not in the completed state. So when we are starting a pod, first of all, my init container will start. It will complete the process which is written inside the init container. And it will be marked as a completed, not as a running. So first of all, when you start, it will go into the running condition. Once it completes the tasks which are written inside the init container, then it will get stopped or it will be marked as a completed container. Then only your business container will start. So there might why init containers are required? What is the need of them? So to start your business application, you might require some of the parameters need to be set. Maybe operating system layer parameter, or maybe some of the partitions you need to create, some of the log files you want to create, some of the temporary folders you want to create, or some of the, let's say that you want to change some kernel parameters. All that basic work, that logic is written inside the init container. So init container gets started first. It sets up all that parameters, environment and everything, and then it will start. Then it will go into the completed state. And once it goes completed state, then another pod will get a container will start inside this one, which will be your actual business container. which has a business logic inside. Okay, so that is the use of init container. So I will try to show you the example also. Yeah, now can you tell me that init sidecar container is something like that? Your business container as well as sidecar container runs together. Init container doesn't run along with your business application. It gets stopped or it gets executed. It is completely state. Right, guys? This is the difference between this. Now, let me try to show you if I can show you some example of the init containers. What is the time, guys? Anyway, but 9:03. My watch. So, guys, can we come back and discuss about this one after the 10 minutes of break? We'll take an example.
Yeah,
And
Ramesh.
then,
Yeah.
thank you. Can stop the recording.
This conference will now be recorded.
So let me show you one example of the init container. So what I was trying to tell you guys, init container is something like this. So you can, oh my God, this is, okay, you can, it should work. Where is my slide now of init container? Just give me 1 second, guys. I'm a little bit not organized properly today because of some other reasons. Where it has gone. Anyway, everything has been given there, but presented it some time back, right? But it has got gone somewhere. Yeah, cool. Yes, Ramesh, you should plan actually. Okay, good. We are missing that actually. All right, guys, init container. So what is this init container? So let's come back with something called as, I always have vada pav first and then start the session. So that is a init container. Unless and until I don't finish the vada pav, I will not start the session. So that is my init container. Are you getting it, guys? So it is specialized containers that run before. I am just joking. Yeah? Okay. Specialized containers that run before app containers in a pod. I just want to tell you one incident behind this one, guys. I don't know how many of you are from Mumbai, but there is one place in the Mumbai called as a DAKC, and there is a gate number 3 over there. And that guy used to prepare a vada pav like anything. People used to carry 10 vada pavs every day in their offices. Okay, so that kind of thing was there.
So is it
I don't
gate
know.
number 3?
Gate
Ambani.
number 3.
Lens.
Ambani.
Mahape.
Right.
Mahape,
Yes.
huh?
Yes, correct. Yeah.
Okay.
Opposite Copper Kerana railway station. Okay, guys. So it is the init container is something like that. It is a specialized container that run before app containers in a pod. Okay, and init containers can contain utilities or setup scripts not present in an app image. So as I told you, it requires, if you want to run some utilities before the your main container comes, you can use init container for that. Are exactly like a regular containers, except always run to completion. They are not kept running. So when you say that is the init container, that container will get executed and will be marked as a completion, completed. Okay. So each init container must complete successfully before the next one starts. You can have multiple init containers also. Let's say you have a 3 init containers inside one pod and one business container, business application container. So one by one init containers will get started, it will get completed, and then your main container will get started. But due to some reason, if your init container fails, then Kubernetes tries to restart it repeatedly until that container succeeds. Until that it is not succeeded, it will be going into crash loop back or pending or some other status. Okay, if you specify multiple init containers for a pod, as I earlier told you, they will run sequentially, right? And who does that job? Kubelet initialize the application containers for the pod after all init containers are completed. So it is the job of the kubelet to monitor the behavior of the init containers, right? So now let's go ahead and start creating the init containers so that you will understand how it is. I hope that you got in a nutshell what is the meaning of init container. So let's write now. Let's go ahead and create one init container. I think we don't have a YAML file for that. I will create this YAML file here, touch init containers.yaml file. And I request Garvit, you can just upload this into the GitHub so that I have created a lot of YAML files here, additional YAML files. Also, I will create the YAML files for the service accounts are also there. You can see, sorry, so storage classes. So we need to take a backup of this as quickly as possible. Otherwise, yeah, Garvit, please.
One thing, Ramesh. So service accounts are already covered in this topic.
Yeah, I have done this for another batch also, right? So I have created for all of you guys. I don't know whether your batch or some other batch, but I have created it. Storage class. Yeah. So these are the additional activities, exercises coming. So it will be handy for you guys, but make sure that you practice it. Okay, so let me, I have just copied this one of the init container definition from the Kubernetes IO. This simple one I'm creating it. So let me copy this. And if you wish, you can suggest me what exactly you want to change. So this is my pod, and this is my app. This is the name of the pod, and this is the label. Okay, and now what is the next thing comes in the pod definition, guys? As usual, specifications, right? And I need to specify the container. So I'm going to write my first container, this one. Okay, so now what I will do? This is my main container. What is this container? You can see this is my app1 container. Coming from the BusyBox, I can use any container here. I can use any image. I can use Nginx also, not an issue. Let it be like this. Then we have to define, this is my main container, right? Now I want to define the init container. So how to define the init containers? So you can use init directly. This is the command. This is the keyword that you need to use to specify the init containers. So let me go here and define this init containers. I hope that this is in line. Cool. Now let me create my first init container. So how do we do that? This is my name and image. So let me pick up this. This is the name of the container called as init-myservice. And this is the image. We are going to use BusyBox only 1.28. What this init container is going to do, that you need to specify here. So what this is going to do, this is going to run this command sh-c. This is a command, right? If you want to execute any command, you can use command. So let me just go there, copy it, and right click. This is a little bit big command, right, guys? So what I will do, ns lookup. I want to complete the ns lookup. This is going to fail. If I use this way, this is going to fail. The reason is that I don't have this secrets and everything. Okay. Okay, let it be like this, guys. You'll see that. And we'll change it later on. And this is my another image which is having the same command, ns lookup command. Okay, so this is my second init container. This is image. This is command. Right, guys? Okay, cool. I can just little bit segregate this. So what it this command, this init containers will do? This will run until the NS lookup is not completed. For sleep, 1 is nothing but 1 second, 2 is nothing but for 2 seconds. So it will sleep for 2 seconds and then it will get completed. Same thing for this also. And once this is completed, then only it will start this container. So let's see that whether this is working or not. Let me save this. Kubectl apply -f init dash containers.yaml. It is created kubectl get pods -oy, and this is my init container. Okay, and if you see here, it might have crashed. Describe my app dashboard. Okay, it is showing completed. No, it is not going. It is not completed. Kubectl and get events. So it is showing successfully assigned default. This is going to worker 1. Created container called as init my service. This is creating another container. Okay, but it is not running. It is still not completed, right? Why it is not getting completed? Because if I try to see the logs of it, how to see the logs of the pod? I can use this command logs of pod called as my app pod. Let's see what is happening here.
Ramesh, you have to remove the pod word.
Hmm?
You have to remove pod word. Yes, now it's gonna.
Okay, so what it is showing, error from server, bad request, container my app one in pod is waiting for start pod initialization. So initialization is not done. But why it is not done? Okay, so if you want to see kubectl describe, let's see that what it is showing. Pod called as my app dashboard. It is not giving me the output. It is showing pod initializing. See here. There are two init containers. This is init my server. This is one container is going on. Okay, and state is running, but it is not ready. It is showing false, and since it is not completed, it should get completed. Then only this container will start, right? So since it is not getting completed, how this will get started? So this is waiting state and initializing the pod, and it is running. It is not getting completed because ns lookup command is not getting completed. So I need to use some different ns lookup service here. I will use google.com. Okay, I think that should work. Okay, so let me change out now, guys. So let me go back to my script.
It will follow the same sequence how it has been defined in YAML file.
Sorry.
I mean, is it going to follow the same sequence? First, it will start
Yes.
init my service and then init my DB, right?
Correct.
Okay.
Do that. So now I'll change the pod name, and here you can see because this is not working, right? So I'll change it. sorry. And I will type here google.com. Okay, so if this is completed, then this container will go into the completed state. I'm not changing here. Just want to show you that how this behaves. Let me save it. My app pod 1, kubectl, apply -f, init containers, YAML. It has created. Now you see here kubectl get pods -o wide. Okay, so it is also still now, till now it is in the same stage. Now we'll try to see what is the problem. Kubectl describe my pod 1, and you can see here now what is happening. Okay, it is showing running. It is false. This is my first init container, right? And where is my second init container? This is my second init container. It is in the pod initializing state. It is still not completed. Let me try out one more time. The same story again.
Ramesh, is the init container, is it waiting for the first one?
So let me change this one now once. I think that is creating a problem. www. Let's say facebook.com, something like this. And let me try to deploy this. Because this condition is not getting satisfied right now. That's why it is creating a problem. Let me save it. Kubectl apply -f init containers.yaml. Oh, sorry, it's typo. Kubectl get pods -o wide. This is started running. See, it has started running. So if you see the describe this pod 2, okay, and now you can see here it has successfully started the init container, created, started, right? And this also created and started, and then only it has started this another container. Now we'll see what is the status of it. So this is my main container, which is in the running state now. And what is it? It is showing echo the application is running. If I try to kubectl, one second. If I try to find out the logs of this kubectl logs, my app pod 2, you can see this is showing output. This application is running. So it is running fine. Now let's see the status of this both containers, init containers, right? So this is my init container, first container, and you can see it is showing completed. So this has been terminated. It's showing because it has completed this task. So it gets terminated. It gets completed, right? And this is my one container, and another container is also in the same range. There is another. This is my another container. It is also showing this command has been successfully completed, and now it is only showing completed. That's why state is terminated. So init containers are the containers which gets executed first, and then it goes for the main application. And now my main application is started. Is that clear? Any questions comes in your mind, guys, about this?
So there are no dependencies between those two init containers, right? Who will start first and second and all that, right?
It will take a sequence, but as per the YAML sequence, it will take it. So whose image will get downloaded first? That is also there, right? Why do I require 2 init containers? Can I do that in one? Yeah, you can do it in one also. But in the real scenario, if you want to carry out one function by one init container and another function by another init container, you can create multiple containers, Abhiram.
Oh, so I can have multiple, or in a single container also I can have multiple function, right? That way, yeah.
Right. Piyush, what is the question?
Actually, Ramesh Garvit told me you have some question regarding the command history. That's why I put up that in the chat box.
Okay, I will just. I'm not able to recollect now what I said. Okay, but if anything
Okay,
is
no
there,
problem, no problem.
no.
Okay, I'm
This
available in the session now, so maybe if you remember anything, I will be there.
Yeah. What I told that I have created multiple YAML files in this Kubernetes folder on the master node. Can you see it?
Oh, yes,
So,
yes, I can see.
We want to upload this into GitHub somewhere, so that another set of the YAML files will get created, or you can add in the one of the GitHub, so that all participants can download this YAML files.
Okay, okay, got it. Like we already have this on the GitHub, and you're saying you added more YAML files in the current one, right? So we can upload these to the current GitHub repo.
Yes, because I have created multiple PVCs, multiple storage classes are there. So
okay, I will push this repo to the push this folder to the repo in current repo. Then it's gonna be fine. I think. Sure.
Okay, thank you.
Okay, I will do this. Thank you.
Thank you. All right, guys. So this is something about the init containers. Now,
so Ramesh, one question: like the init container is taken care by the word init, right? The moment we write in hyphen, it means that it's a init container, correct?
Correct. So that is the one thing identification for it, and Kubernetes understand that.
Okay.
In normal containers, we are using containers, but if you want to determine this as a init container, we can use this particular.
So it's an array only. Like even if you're using a single init containers, the init need to write init containers, right?
Right. It is array. Similar like this one, it is also array.
Yeah, and one more thing regarding the name. The name is it's include init hyphen my service, so it has nothing to do, right?
No, I can use Vadap also, no problem.
Okay, fine. Yeah.
So this Ramesh, this init container should be in the same container, right? It cannot be loosely coupled to another pod, right? I mean, as we saw in sidecar, so we cannot have this.
It is inside a pod.
So init container, I can separate it out to separate pod? No.
No. That is not possible.
Okay.
It is within the pod. Basically, basic idea of the init container is to set up the environment for the main container, whatever the environment will be, in any form. That is the use of. Okay, guys. Okay, so now we have completed this.
One more question. Like so, we can use init container just to check like if some systems are up and running. Can this be the example?
That can be the example, or otherwise, if you want to set up some paths, some environmental parameters, some kernel parameters, or if you want to install some packages.
But we may not. Okay. Yeah.
Okay.
Thank you.
Thank you.
So one question more. So how we can link different type of services or commands in the init containers? Like you are creating one container which requires to be created before other containers.
I'm trying to understand what the way I should. So you are saying that
for example, database container is required to be created before web application, like that.
You are saying sequence or
Yeah,
yeah,
sequence. Yeah.
yeah. In that case, you can write here. First of all, see basically then in a one pod you will not be able to do that. You in a one pod you should not do that actually. If it is a database container, you will have a different this one. But if at all in one container in one pod you want to create a container called as a database container, and then you want to start the application container, then make sure that you define database container first and then define the application container.
Yeah. Yes, something like that. Yeah.
Yes.
Thank you. Yeah.
And you add some delay, okay, because there should be some time database container should it will take some time to complete the database. Then what you can do, you can say that unless and until the database container is not running, you do not start the application container. For that purpose, you can write a init container, something like that. But that will not be useful in that case. So first of all, you write a database container and then you write the sequence syntax for the application container. Okay, that is the bottom line. Now, I hope that everybody has understood about the sidecar containers, sidecar patterns, as well as you have understood the meaning of init container. Let's move ahead and discuss about what is the next topic is Kubernetes maintenance, and then we'll go for the stateful and headless service. So guys, I will take the stateful and headless service first, and then I will keep the Kubernetes maintenance back because it is easy kind of stuff. Kubernetes maintenance, where we will just cordon up the services and nodes and all that. But before that, let's take a stateful and headless services. Okay. Now, guys, this is very important discussion. Stateful state. Stateful states, right? Is this a stateful state is an object? Is it a kind? Yes, it is a kind. So how do I find out that information? kubectl get sts. Do I have any sts in the default namespace? No, that is nothing but a stateful set. Do I have any stateful set inside the kube system? I will explain you this, guys. Don't worry. Nothing is there. And how I can create it? I can write the YAML file for this one. How to create a stateful set. What is this actually? What happens, guys? You tell me the sequence, one sequence. Let's say this is my pod, or this is the deployment. Consider this is my deployment, and there are 3 replicas. So 3 replicas are running right now, and suddenly, what we decided, we have decided to delete all these replicas. Deployment is running, replica set is running, but out of that 3 replicas, we have decided to delete all the replicas. So the normally, let's say the name of the deployment is db1, something like that. Then there will be some numbers here, 4, 5, 6, 7, something like that. It will come up. This is one replica. Then there you have another replica called as db1 dash something. Then we'll have a third replica called as db1 dash something, right? If I delete these replicas, what will happen to the name of the replicas and IP address of the replicas when they recreates it? Because by default, the behavior of the deployment is that in case any replica is deleted or terminated, another replica will get started. What will be the name and what will be the IP address of the new replica? So in the deployment state, what happens? The replica name also gets changed and IP address also gets changed, right? So that is the problem, right? In the applications or in the case of databases, right? If your database name is going to change, database replica set name is changing, or the IP address is changing, then it is a problem, right? So for that purpose, you need to have a one setup which will keep the track of replica names as well as it will keep a track of IP addresses. So it should not change it. So let's see that how to write a replica, how to create a deployment by using the 3 replicas, and how we can create a stateful set. So deployment is the object. Similarly, stateful set is also object. So what is it? Let me show you guys. So I have a stateful set, one of the definition here. So let me show you this. Yeah. So deploy stateful application. So we were just discussing about the database. So in case your replicas get deleted, terminated, and you are creating a new one, it doesn't keep the state, existing state or earlier state as it is, right? It creates a new one. So if you want to keep the state as it is, right? So you can deploy this as a stateful set. So now what it does, it provides a high availability. It is something interesting. Of course, deployment or stateful set in that nature creates the same number of replicas in whatever you defined in the manifest file. So high availability is nothing but in case my one pod goes down, another pod will take care of my application. It is a self-healing. So similar like a deployment, stateful set also will have the self-healing. There will be cluster IP service will be exposed within the cluster, right? As a deployment, database app as a deployment. What is another feature of the deployment? If you are deploying the database application, all pod comes up at once, right? Pods can't be marked as a master or slave inside the deployment, because the problem here is in the database. Let's say that this is a database application and you have 3 pods running here, which are the database pods. There is a service here, and now this is, let's say, service. Customer is trying to access the database, and this service has now marked this as a pod. So whatever the transactions happening, that will get stored inside this one. Another user is requesting the database, and it is pointing to this one. So data will written here. How this data and data will get synced up? If third request comes and it goes into inside this one. This is the problem if your database application is deployed as a deployment. Because in deployment, nobody is a master and nobody is a slave. So all the pods will contain some data which is not consistent at all. So some data will be available on this pod, some data will be available on this pod. This is the problem if you are deploying the database as a deployment. And this is what it is written here. That pod can't be marked as a master or slave. In stateful set, you can do that one. You can mark as master first one as a master and all other nodes as a slave. So if data is written into master, then there is no problem. But if somebody has added some data into slave, it will immediately get replicated here. Right? Or if something has marked here, immediately all other things will also get replicated on this one. So in the master slave format, it will try to keep the equal information on all the database pods. Okay, so that way the information will be consistent and it will be in integrated format. So that's why pod can't be marked as a master or slave. Now let me move ahead. Let me erase this. Service by default does load balancing across replicas and can't mark replicas as a read replica or write replica, right? So there is no concept of read replica and write replica. So all of them are write as well as read. So this is the issue with the deployment kind of stuff. So what is the advantage of how this problem is solved by using the whatever the deployment issues which you see here, that is solved by the stateful set. So you have a service. So this is called a stateful set service. You can say that this is your pod. This is something called as SQL0. The nomenclature will be numbered very nicely to the pod. So you are saying that I want 3 replicas of this one. So it will create a 3 replicas. You can see, and it will be named as SQL0, SQL1, and SQL2. And I think in this one, SQL0 will be marked as a master. Okay, so here master is SQL0. Look at this. Now, so this is your something stateful set will look like. So it has a headless services. So this is again something interesting stuff is there. I am going to explain you that what is the meaning of headless service after the once the stateful set is completed. So if something goes wrong with this pod, then what happens? This you still have another pods there, and if this pod goes down, which is right now master, then SQL1 will become a master. If this goes down, your SQL2 will become a master. So automatic handover of the master algorithm is there in the stateful set, and it can hand over the master status to some other pod as well. So what is stateful set now? So it is used for stateful applications and distributed systems like databases. So for a stateful set with n replicas, pods are created sequentially in order from 0 to n-1. So what is the meaning of that? You want 4 pods. So first pod's name will be 0, second 1, 2, and 3. So that way, that's why it is n-1. Pods in a stateful set have a unique ordinal index and stable network identity. This is something interesting. So this, even you terminate the pod, the same name will come again. It will not change. That is nothing but a ordinal index. Number will be kept same, name will be kept same, and its network identity like a IP address or that way it will be also kept stable. It will be as it is. So the rolling after strategy updates all pods in a stateful set in reverse ordinal order. So it will go for 4, 3, 2, 1 like that. So if the controller deletes one pod at a time in reverse order with respect to its ordinal index. So if you want to delete some pods, or let's say stateful set, then it will delete the 4th number pod, and then it will delete the 3rd, then 2 and 1 and 0 like that it will delete. We are going to see this practically, guys, now. So this is something about the headless services. So we'll come back to the headless services, guys. So let me first of all deploy the stateless service, stateful set now. Okay, so let me go to this place. Right now, I don't have any stateful set ls. Is there anything?
Ramesh, can you please explain the 4th point?
Which one?
The rolling update strategy one. Yeah.
Okay. Rolling update strategy updates all pods in stateful set in reversal order. So what is the meaning of this? Let's say that you have 4 containers or 4 pods are there right now running, and they are stateful sets. So its number is 0, 1, and 2. So now what happened? You want to now do some rollout, new rollout. That means new version has come up and you want to roll out. So whatever the rolling update strategy is there, maybe a recreate or maybe a what is it called as rolling update. That is another policy itself. Recreate, rolling update, or canary deployment, or maybe some other deployments are there. So what happens whenever you try to upgrade your stateful set with the new version of the image, First of all, it will do this one, second number. Then it will do the first, and then it will go for the 0. So this is called as the reversal ordinal index. Okay?
Okay, understood. Yeah.
So let's guys create our own stateful set now.
Ramesh, what is the default one?
Rolling update. kubectl create deployment, okay, from the image nginx, right? I have not given the name. So this is my D1 deployment. kubectl scale deployment /D1 -- replicas is equal to 3. kubectl get pods get pods, let's say -o wide. Can you see this is running right now? Let me delete these pods, guys, so that we'll have a clear picture now. kubectl delete pod mini sidecar. How to delete this in one go? That's why I create new namespaces. Okay, now it is getting deleted. So I'll have only deployment there. So now I think I have another terminal also. Now you can see a kubectl describe deployment called as D1, and you can see here strategy type is a rolling update. This is a default strategy. Okay, now kubectl get deployment. You have D1. kubectl get replica sets. You have one, right? And kubectl get pods. You have 3 pods. Now what I'm going to do, I'm going to delete this replica set. What will happen, guys, if I delete the replica set? Anybody would like to tell me?
Yeah.
Recreate the pod.
Will be recreated.
Now see, kubectl get deployment. We have D1. kubectl get RS. Sorry. See the name here, 6594 6549, right? It is same to same. So even though I deleted the replica set, it has created a replica set with the same number. But then what has changed? See, the numbers are changed for name, and as well as I should have shown you this way only. This might have changed. Yes, because now it will not be available. Let me delete it one more time. Delete. Okay, and now let me. It is creating. So let's wait for some time because I want to show you that what is happening to the IP addresses, whether they are coming same or different. Sometimes they will come same also. Yeah. Now see, the IP address of the pod 1 is 10.40.03. Another pod is 40.0.4. It is changed, completely changed, right? So different names have come up, different IP addresses have come up. So it is not having a stable identity, network identity, neither it is keeping the same names also. So that
In
makes
different
it,
nodes also.
yeah, and nodes may also get changed, right? So now stateful set will help you to achieve this, keep the stable network identity. So how to define the stateful set? Let me just try out, guys. I have not tried any time by using the command line. I always use the YAML file for the creating the stateful sets. Let's say S1. I'm creating this image called as Nginx. Nginx, right? No, it is not picking up. I was just trying it. Kubectl create sts --help. Okay, guys, it is not showing me that output. Stateful set is not coming here. So now let me just go to the kubernetes.io and get one sample file for the this one. Stateful set Kubernetes example. Let me go to this one. And do I have one? Yes, I have one. Can I use this normal one? Yes. This is my stateful set. Kind. Name of the is web. Service name is Nginx. Replicas 2. Template. This is a container. This is a mount point. So it's a little bit bigger one, but I will just modify it. Let me copy this.
Is it a deployment?
No, it is STS.
And why it is mentioned replicas as two? So in stateful state also you can define replicas, right?
Yes.
Okay.
Let me just complete this one. Okay, now you can see I'm just removing this volume because I want to make it very simple. Okay, and I don't want to confuse you also by the service name. So kind is stateful set here. Now see here. And what is the API version? I have not mentioned API version here. Mentioned. It is a app/p1. Metadata is this is the name of the stateful set. How many replicas? 2 replicas of Nginx will be maintained. What is the image? This is something slim 0.8 some Nginx image is there. Let it be like that. Okay. So now let me create 3 replicas of it. There is no logic of 2 or 3, guys. Just I'm just choosing that way only. I like 3 number. That's nothing else. Kubectl apply -f sts.yaml. So there is some error it is showing. So what is that error? Service name is missing. So service name is another. This is another one field which need to be added, guys, which I deleted, right? So now see, this is service name. Okay. Now let me put it here. Kubectl apply -a. Yes, it is created, guys. Now see, kubectl get sts. Still now it is not ready. So you can see a kubectl get for -o wide, and you see that. Okay. 3 replicas I have mentioned, right? So see here, it has created a first container whose name is 0. Then it is creating a second container whose name is 1. So it is not creating in one go, right? So first of all, it has created wave 0, wave 1, and wave 2. So no random numbering will be given. It will be in the sequential indexing, right? And this is running IO, and this is the IP addresses. Okay, so rest of the things are same, like a deployment only, but only thing is that the networking part is used by the headless service is used for the forwarding the traffic. So kubectl describe. So before that, let's delete this one. Let's delete pod called as web1. What is its IP address? 1040. Now let's see what happens. So it is deleting. Let me now get what's happening. Can you see it is creating that container itself, web1. It is not creating a new container with the same index number it is creating. And it is deploying on the worker 2 only. And I think, yeah, IP address should be also same. Can you see? 10.40.0.5.
Delete the replica set, please.
Kubectl get replica sets. So you have only one replica set. There is no replica set for the stateful sets. So this is my deployment earlier one, this one. Okay. So now, what should I do now here? So even if I delete any pod here.
So what is the equivalent for replica set here?
Nothing is there. 1 second. Okay. It is stateful set is maintaining it, and that is nothing but headless services is doing this job.
It's like magic show actually.
Hmm?
It's like a magic show.
See now here. Even if I delete the web 0 pod, it is coming as it is.
Ramesh, so what is the use case for this stateful set?
Database, deploying a database. Okay. Now, if you want a sticky sessions, if you want the even though something goes wrong, you have to have it, right? So now, if can I scale it? Since there is no replicas, I think it won't be. Let's say fine.
Normally, Ramesh, stateful set is used for database, not for the application. That is why since it requires some persistent storage, right? Database requires some persistent storage. That is why we use stateful for database perspective, not for the web application.
Right. So I just told that if somebody asked me the question, what is the use case, right? So guys, make sure that it is mostly it is used for the stateful. It mostly it is used for the sticky based or databases, because database is required sticky sessions.
Ramesh, meaning that stateless will never require a headless, right? That's how we can conclude, correct?
Right. Yeah. Now we'll not discuss about the headless because we have not taken the point of the headless services. I just want to focus on that. If you are creating a stateless set, stateful set, it keeps the IP address same. It keeps the name of the server same. And even if you are deleting the master, this is your master node. This is your master one. Even if you delete it, it will recreate it again quickly.
Again, we don't need replica set for the database because database is on the primary and slave concept, right? Read and write and read replica. I would say the primary and replica databases, right? It is not like multiple pods or multiple database server, master and slave concept, right? In database. That's why stateful will be better fit in that requirement.
See, basically, that is a very good point, Vivek. But one thing is that STS allows you to create a multiple replicas. That is one thing. Okay. Now, in which case you would like to scale up your databases? And what is that scenario? The scenario is like this one. If you have, let's say, 5 replicas of the databases, this is DB1, DB2. So 5 replicas, these are the 5 pods or 3 pods are there. They are a stateful set. Even though they are in the stateful set, you can have a persistent volume attached to them. So whatever your logs are there or whatever there your databases things are coming up, save here inside this one and map this storage to each database. So what is the advantage of this one? Now, if my load is increasing, if I need more replicas of the databases, I can still have, right? I can create still more replicas because my data is on the external storage. So this is the basically way you can increase the replicas. Okay. Another important thing is that you can use this one set of this particular replicas as a read set, and another one set of the databases you can use as a data
But
write.
Ramesh, normally you think about not in importance. Let's say you have a database server, whether it's any database, right? In the normal scenario, you have a what we call the write database, and the other one is your read database, master and slave concept.
You can say mainline database, right?
Right, and both databases basically has a different persistent storage, right? You cannot use the same storage for read database and write database.
Okay, you are saying that in real
Because the
scenario,
replication will be happening from your master to slave. So both cannot use the same persistent storage when you have two databases. One is on your master and the other is slave.
Okay. Okay, no problem. So you are saying that some of my services are, this is my database, mainline database.
But you have, let's say, two-tier application, right? One your web apps and the backend storage, front end and backend, right? Front end is your application, web application, and the backend is your database. Now you have a database, you have master database and a slave, right? And replication is happening on your database master to slave, and
Correct.
both the database has its own persistent storage.
Okay, correct. So basically, this is the case that you don't want to load your master database, right? So you want only some of the operations to be happened on the master databases. All other reporting operations or
Yeah,
creating
read will be done to the slave, and write will be done on the master.
Right, absolutely correct. But only one thing was there that is absolutely correct. But if it is a container based app nowadays, and if you have, can I have, this is, I want to have 5 pods which will behave as my master database master node.
Oh, you mean to say high availability?
Yes, high availability. And if there is a possibility that there will be a lot of writes will happen. Let's say 1 lakh people on 31st March, 1 lakh people are trying to write the data inside that database. So how you are going to scale up that, right?
Wait a second, Ramesh. Say, for example, if you have web 0, now it will have the containers inside, okay? The database container. So one database container can be read and other container can be something else.
No, that you cannot do that.
Okay.
That you can't. You have to expose this particular application STS using some service, and from that service, all this will be. Let's say these are your 5 pods: web 0, web 1, web 2. You will have a service here, and this will load balance it. So it is for better for the high availability as well as.
So all will be read write.
All will be read write.
Okay. Yeah.
But
that
you
makes
can.
sense. Yeah.
That is another business logic you can create. You can create another set of the replicas here, and you can another set of the pods, and you can make them a slave database
Yeah, you
servers.
can have a virtual IP for write operation or read operation, something like that. So it will go to specific node. Yeah.
So is it the statefulness is needed for database containers? Is it because it is going to retain the name and the IP address?
Yeah, it is going to retain the name and IP address. And I told you before going to the stateful set, we discussed about the deployments. These were the problems of the deployments, right? As a database, as a deployment, we have discussed this one.
No, I'm just trying to understand, Ramesh, that why only statefulness is needed for database containers? Why not for application containers?
Right, Samantha. Let's understand that if you are database and you have a name, if there is no dynamic if the IP address is changing, right, every time whenever the pod is deleted or the name is changing, then how your web application will be, you need to change your web application configuration again and again to map it with the new IP and new thing, right? You need to have some static information which always be constant so
We
that
can
your application
use
can
right
talk to
in that
database.
case. In that case, we
Yeah,
can use right?
I do understand this, but then I'm thinking why the same scenario is not applicable for web applications. So your end user is using your application, front-end application, okay, and your application server, let's say it's a Tomcat or something, okay, that is hosted on a particular container. It is
You
having a
use service.
sorry.
You use service, right, for the web applications.
Yeah, yeah. So it
Yeah,
is having a name and a IP address,
yeah.
right?
It doesn't matter even the backend ports are changing, IPs are changing because you're routing the traffic through the service, right?
Through the service. Okay. So even if the IP changes, it is not going to impact the end users.
It will not impact. Yes.
Okay.
Now
Okay.
think about this one, guys. This is my deployment, and answer to your question. This is my DB1. So these are my database pods. Okay, fine. And this is deployment. This is not a stateful set. Now, what will happen in the case? Let's say that you are trying to write data here. You are trying to write a data. So this service will distribute the load here. So sometime data will be written here. Sometime data will be written here. Sometime data will be written here. Okay. How you can make data similar on all pods?
Same
Forget
volume.
about, okay, it is in volume, right?
If replication is there, it has to be done, right?
No, deployment doesn't have the replication, right?
Okay, but in normal, like if you don't consider this scenario pod and all, in normal web application, whatever database if you're designing, it will be replication will be there.
So I'll tell you this is one. What is the advantage of the stateful set? Now you got this, right? So if somebody is writing a data, let's say a person is coming here and its data is stored here. Think about that. You don't have the volumes here. Think about that. And another person's data is stored here, and third person's data is stored here.
Data is stored locally then.
Just giving you an example. And suddenly something has gone wrong. How I can make it together? This is one thing. But if I deploy this with the help of stateful set, there is a concept called as a master here. This pod will become my master, and another pod will become my slaves. Okay. So in this case, it will try to replicate the data. They have an algorithm so that the data which is across these pods will remain same.
Can't you use the same volume? I mean, which has been shared by multiple pods, so that the data will be replicated and it will be used universally by all the pods.
No, that is possible. You can use that one. And another important thing is that, guys, what happens? Let's say that right now my database is serving the request coming from the users, and there is a one connection established here. So it is always better if you have a fixed IP addresses at the backend pods as well. So it will allow you to create a stickiness, or it will allow you to create the some transactions or financial transactions are there which need to have a stickiness. What is the meaning of stickiness? If some transaction is coming, let's say a transaction, it should always go to the pod one, and you can define that one. And in that case, you need to have the name of the pod and IP of the pod. At least name of the pod should be constant. If the name is changed, then you cannot do the stickiness. You cannot allow the sticky transactions.
Yeah, I mean, as far as sticky transactions are also concerned, I can understand this concept is going to work. But then when it comes to data replication, either we can go with volume, okay, mapping the volume, the common volume to multiple pods, or inside database itself, we have data guard concept, okay, where the data will be replicated and a similar copy of your production database will be hosted in a different site, okay. And whenever you write something in one database A, okay, automatically the data will be getting archived, okay, and they will be applied to another database, okay, to maintain the same copy of your production database, as Vivek mentioned there. So in database world, okay, it is called data guard, okay, where you have a physical data guard and you have a logical data guard. So in physical database nowadays, read and write is also allowed. Otherwise you can go ahead with read only database, which is only used for reporting purposes, for
Right.
pulling.
Now,
Yeah.
I got your this one. This is my service. The data request is coming here, and this is my master pod. And you say that in the master pod I should have a write permission, right? So this here you can write the data, and you can use this pod as a read pods. This is only possible with the help of stateful set.
And while creating those containers, we can define whether we can be using that container database as a read or write.
No, whichever one is the first one, it will behave as a master.
Oh, so that is default.
Right. And because
Okay.
of some reason, if this is not working or creating a problem, it will recreate the new one. And if at all it is not working fine, it will make this as a pod, as a master pod. You can have volume here, there is no problem.
Can you have multiple master?
As such, not required.
No, but just because of the load.
Because it has a self-healing methodology.
No, I'm talking because it might have high load and all that, right? So
yeah. So in that case, as per the structure which I understand, you cannot define the two masters here.
Don't think in database world you have a multiple master.
Normally we don't have.
No, I mean, so just think of, the real application clusters. Okay, where database, there will be multiple nodes, although the data is common for all the nodes, but then the processing is going to happen in multiple nodes at the same time. So, I mean, in database world, that is called real application clusters, RAC databases. Okay, so where load,
we have to deploy that application. Then we have to deploy that kind of application. We have to check whether RAC is supported by the container or not.
Okay. All right. Thank you.
All right, guys. Okay, I hope that you understood what is the meaning of stateful set. Keep couple of things in mind, guys. That whenever you are deleting, whenever you are deleting any pod, which is a stateful set, just 1 second, it will recreate the pod with the same IP address and same name. This is one thing. You can scale up the stateful sets. That is another important thing, right? And it is always better. And whichever is the master pod is there, it will have a ability to write, and other pods can be used as a read pods because there will be a slave pods. Okay, yeah, go ahead and ask the question.
Yeah, now it's fine. Yeah, clear. Yeah, what I wanted to ask was the same volume. So you have now cleared, like master will be only writing into the volume and the other parts will be do a read operation on volume.
Right.
Slave.
Correct. Slave.
So one more question: where is this replica, default replica is defined? Like first time you showed 3 web application where 3 was given replicas. After which you made the replicas equal to 5, then it became 5.
Right. So how I did that one? That is what your question?
Yeah.
No, I just use this command.
No, but when it was deployed in the first deployment of the STS, so that time how it become 3?
I gave here 3 replicas.
Okay, I got it. Yeah. Thank you.
Ramesh, the one which the replica is something to do with headless, because that I was confused. Maybe I missed that. Like the headless is same as replica, or that's a different context altogether.
That is basically a headless is used for the transferring the traffic, forwarding the traffic.
So both works together. Is that how?
So
In the case of
that, yes, it both works together. So I
in
just
case
need
of
to explain.
stateful. Okay.
Yeah, just give me some time. I will try to explain that also. Otherwise, people
Stateless will communicate with the stateful.
why not? It will communicate. It has IP address. It has the services. Everything is there. It will communicate.
Ramesh,
No, that is what I'm saying. So stateless, headless application basically talk to stateful application.
No, headless is a type of the network service. It is not a application deployment type. It is just the networking.
Ramesh, I skipped that headless
Yeah.
part, so I don't understand that at all.
No, I have
so
not.
If you're going to explain that in future, then that's okay. I can wait. Otherwise, we can understand now.
Yeah, that is the next topic that I am going to explain. What is called as headless services. Okay, so headless
Ramesh,
service.
one more. So when
Yeah.
we describe Web 0, we can see that it was assigned as master, or it has a right operation, like permission.
Acha, okay. Just let me just try to show you how I can show you that. Describe STS.
Was
Where it is different. That is your question, right?
Correct.
Yeah, actually, we haven't declared whether it is declared by default or we need to provide.
Actually, it is defined by default, but I am just trying to see where it is defined. So it is by default. Whatever the STS code is there, whatever the logic there is in the STS, that logic defines first pod as a master pod. But how to check that whether that is my first pod, that is my master or not?
So maybe if we describe the pod Web 0, try that as well, if possible.
That I haven't tell. But good question.
Or from the name and the IP.
No, that way we can identify easily. But is it written somewhere? Describe pod. Namespace is default. This is my worker 0. This IP address. Controller revision finish.
I don't think it may be business logic. You need to define that is a master or is a read replicate.
No. It is act as a first node acts as a first pod acts as a master. Okay, I think it is not mentioned here. This, if you try to read this STS document also, let me just try to see if I have. They might not have given the working also. The pods in a stateful set have a sticky unique identity. Okay, so that's fine. No, it is. I think it is not mentioned. I'll check it and I'll come back on this one whether anywhere it is mentioned or not. This is a master or that is this one, and how to find out the master node, right?
I think here we could see something read write operation access mode somewhere output get PVC. Okay, this is something different.
Read write access mode is there. This is for PVC actually. Okay, I will just check out, guys. I will not spend time on that. Anyway, time has been gone away. Okay, I will check that, guys. Not an issue. Keep the tally. No, it is showing just Web 0 has been created. It is not showing any other information as such. Okay. I'll check that, guys. Not an issue. It is not a big deal. How to find it? That means we are going into the deeper side of the stateful set, and that's fine. And the last point I wanted, any other question on the stateful set, guys? Anybody have? I hope that I have answered everybody's questions. I have the problem when I deployed a cluster using flannel network with all CentOS VMs in VirtualBox.
Yeah, that was my question. Thank you.
But is it answered by anybody? No?
No, you were asking about what?
Your question you have mentioned. I have the problem when I deployed a cluster using flannel network with all CentOS VM in VirtualBox. What is the error you are getting?
I actually wanted to do the stateful deployment, so that's why I was referring to if I can use in that.
No, you can use there. You can use any. If the
My
Kubernetes
question was
cluster,
on the cluster IP. So when I deployed with the flannel network,
okay. I think I'm not able to hear you, Arun. All right. Yeah, that is also correct. This is interesting, Abhiram. This is one of the things that is important here. During master switch over, data also gets synced up. This is important. So data is already there in the, let's say, volume, and when you make the when the master pod is not available, whichever is the next in the sequence will become a master. So data is static. Data is there only.
Oh, so data will be synced. So the data will be synced up, right? I mean, in the sense like it's a volume. The
Yeah,
data will
it's
be
a
there.
volume. Yeah, since volume is there, if the data is available on the volume, and it should be available on the volume only.
Mm-hmm.
See, the
So
data about metadata is synced up, replicated from master to slave, but actual data itself in your persistent storage, which is common to all the master and slave.
right, Vivek, correct.
And the state of the database will also be changed from read only to read and write. Sorry, write, right?
For the another pod, second pod. Yes. The cluster IP was assigned automatically. I wish to change it. I could not find where to change. Why you want to change the cluster IP address?
yeah, because normally part of the network planning, so we define everything beforehand. So we don't want something to happen randomly.
Cluster IP address is, but the IP address which is coming from the internal configuration only.
Yeah, internal for the pods network.
Right. So there is a if you go to the flannel cd/some etc cni, you can see here there will be some configuration details here. So this is we are using a 10 view.conflict.
Okay.
So somewhere it will be there in that one. As well as you can define the when you create a kubeadm command, when you bootstrap the cluster, that time also we can define the range as
Yes,
well.
but anyway, so it was working. So I could make it work. My Nginx application I could access from outside.
No, through the cluster IP you will not be able to access it.
No, I did expose to the port with
Port.
IP address. Exposed,
Yeah.
yeah. I exposed outside. Yeah. Thank you.
Okay. Yes, Ranjit, it is correct. So that is what I was trying to show now. See here, if I try to kubectl get sts, correct, right. And if I try to delete the pods, kubectl get pods are there. And if I try to delete it one by one, see here now what is happening. Let me keep the watch on this one. Yeah, please mute guys. Okay. And let me try to delete one by one. Kubectl delete pod web-0. See now what is happening. It is terminating and it starts creating a container also. So can I delete web 1 as well, web 2 as well, and see what happens now. See, so it is creating a first container, then it will create a second container, web 2, web 1, and then web 2 is getting created. You try to delete all also, the same thing will happen. 3 and web 4.
So there is no downtime.
Now see here, all of them are getting terminated now. There will be downtime in this case if I am deleting all the pods.
Yeah. Okay.
Now see, now it is creating a first pod, web 0. Then it is creating web 1. Then it is creating web 2. That way too. But what are the chances of getting deleted this kind of situation? This kind of situation will not be there, right? In one go, the pods will go down. So if the pods are going down, that means your HTS is also down.
So
Okay,
here,
guys?
Ramesh, is one thing observed is like master get created first, right? Web 0, I was assuming web 0. So when it
Yes.
deleted everything and it deleted master at the last, right? And then it created master at the first is what I observed. Is that a right observation or?
Yes, correct. Now see again. Now creation will, see, the last will be web 0. Now it is creating a container. So that is what the statement was. When you are deleting or when you are updating, it will be in the reversal ordinal, index ordinal, and when you are creating, it will be from the 0, 1 to 3. Upgradation and deletion in the reverse order, and starting or running will happen from the 0, 1 to 3.
Yeah.
All right.
Makes
Yeah.
sense.
All right, guys. So let's stop here now. We have almost 5 to 6 minutes. We have completed the session, and now we have not completed this point: headless services and Kubernetes maintenance. So in the next session, we will complete Kubernetes maintenance, headless services, and some other parameters we'll try to see.
That's a
So we
maintenance
have
and troubleshooting, right, Ramesh?
yeah, maintenance and troubleshooting. Yes, we'll cover up that one, maintenance and troubleshooting.
Will it be weekend class or weekday?
Next Sunday, right? Next Sunday.
Next Sunday. Yeah, CK batch will be next Sunday.
Yeah,
CK
that is good. Yeah. Yeah, good. Thank you. It is difficult for me to attend in weekdays.
Yeah.
So the time is very crucial for me.
Yeah. Okay. Okay. And
Thank you,
we'll
sir.
try to we'll try to add a couple of more points also in this one, along with the Kubernetes maintenance and troubleshooting, headless services, and some one more point I will try to add. Yeah.
And one more point is there are different type of network plugins like Calico, DynamNet. So is there any possibility like so when I tried with Flannel, so there is a process how to migrate from Flannel to Calico. So it is not a simple process. So if you can throw some light or some.
So process is very simple. Process is very simple. Only thing is that you need to take a backup of the etcd cluster without any fail. That is the first thing. And then you see here kubectl get pods from the kube system.
Yeah, I tried to get into the etcd, but I could not got into.
One second. No, migration you were asking, right? So what you can do?
Yeah.
You have this view network.
Yes.
I have used view. Now I want to use Flannel. So what I will do? I will delete this. So once I delete it, what will happen? Kubectl get node. They will not be in the ready state. They will be in the not ready state because 3 of them are now disconnected. And the moment now you can deploy one more Flannel. You change the plugin, use a Flannel. Then your new network will be added, and you will see that your 3 worker nodes cluster is in the ready state now. Then. So that time one more thing will happen. Your core DNS will also go down. So operations will be completely down if you are migrating your from one plugin to another plugin. Please keep this in mind.
Okay, so I have to delete the delete
This
it
one,
first.
this
Yeah.
one only. First of all, take a backup of ATCD. How to take a backup? We have one class. I will show you that how to take a backup of it.
Yeah,
master.
yeah. I could not execute a etcd command to get config something. So the way it is saying core DNS set core DNS get core DNS, I could not see get command. Set is a different thing. So
Don't
I don't
worry.
know. Yeah.
Don't worry. I will make sure that it will be work, but you need to wait for some time. I will definitely
Okay.
take. Yeah.
Okay. Thank you. Thank you, sir. Yeah.
Thank you.
Ramesh. Okay, sorry. Go ahead.
One.
Yeah, so thank you. Just two things like service account and storage classes, like those topics were already covered, or like will it be covered in the next?
Storage classes, I think I have not covered. I have covered persistent volume, but I have not covered storage class for you, right, guys? I don't remember that one. Because storage
Yes,
classes.
storage classes are not covered. I think you are going to cover under the AKS.
Right, dynamic. Yes.
Yep.
I will cover in the dynamic provisioning. Yeah.
And the other one, like service server.
Akhil, service accounts, I think we have covered, if I'm not wrong.
Yes, service account
Is it
was
like metric
covered.
server?
Service account we have covered, yes. Yeah, go ahead, Akhil.
Is it like a metric server creating, that is a kind of service account? Or?
No. Service account we have seen in the RBAC.
Okay, okay, got it. Yeah.
If you watch my lecture, that RBAC lecture, I think you will get that somewhere.
Yeah, thank you. Sorry, guys, you can continue.
Ramesh, I have a question on while we are starting this classes CKA. So at the time, someone was raised a question of Istio. Istio topic will cover in this CKA. So is that still we are on the stick to that, or else any changes?
Let me check out the schedule. Somewhere the schedule was given. Just one
Yeah, CK. I mean, Istio was under CKAD. I mean, not under the CKA.
It is inside the CKAD only.
Yes,
but
but
yes, it is not under the CKA.
Yes,
program.
that's right. That's right. So, but due to the students' requirement, I mean, asking that, hey, why can't we include that Istio in the CKA program? So at the time, the first classes, I think I do remember someone raised this concern, and everyone else, I mean, Atu or someone says that yes, it's possible to adding of that Istio in the CKA. So still we are sticking to that, or else there is any changes.
Okay, let me take up this
It is
bit now.
part of the sidecar portion. So because Istio is a sidecar pattern, so it should be good if you can take it up with the same thing or extended class.
Okay.
Because
and also Ramesh, it's more of like where your ingress agrees or more towards to a mutual TLS. So those definitely will add the value for Istio, right? That's where we use it, right? Istio. So that way
I will discuss your request with the K21 guys, Atul and other people, and I will come back to on this one. If they add, that will be great, guys. Not an issue.
Yes, Istio adding to the CK is going to be very benefit to us. So
correct.
That is as a special request from all the students from the CKA.
Okay. Thank you very much. No problem. I will just talk to you.
You can get Istio also. Very much helpful.
And also,
I just want to ask one question, guys, to all of you. Are you really doing a practice on these topics which I am explaining you?
I am doing the practice whatever you are doing. So on my CentOS based cluster.
That is okay. That is, you can use anyone, but please make sure that you follow the practice. You do the practice. Otherwise, there is no point. The sessions will get over and you guys will lag behind. So I don't want to happen with you guys.
Yes, every time we are going as an active guide and we are finishing that, and also we are going to this. From my point, yes, we are covering, but the only one thing is not repeating. That's the main thing. So right now we are on the 17th day, and again, if you want to jump onto the something like day 5 or day 6, just reviving of that classes is not happening. But yes, that is need to be have. But every day coming to the class, the previous class will be covered. That's what I'm doing. I don't know the other one, but yes.
Yes, sure. So that is good. But guys, make sure that, because this is really, really important thing, and I'm spending a lot of time with you guys. I'm putting my all efforts. I'm trying to answer all your questions. But if you people absorb that and implement that in your projects, or uh, for the clearing the certification, or maybe clearing your interviews, that should happen. Otherwise, classes will over and you people should not remain. And we should not spend much time on this one. There are lots and lots of technologies that are there. Okay, and you have to grasp this in anyhow in the 3 months or 4 months of time, right? So make sure that you prepare a plan and accordingly prepare it for the examination, prepare for the interview, or maybe for your projects.
Yep, definitely we will take that as a granted one, and we will take a look on that.
Yeah,
we are following those. Definitely we are following that.
And Ramesh, that Kubernetes networking was covered earlier. I just want to make sure that.
We have covered now. We have discussed about the node ports and everything.
Okay.
Do you remember that topic, node port topic? I was covered. I
Yeah,
discussed that.
node port, the load balancer. That
Load
one.
balancer as well as, and again that will come in the ingress controller as well.
Yeah, it was covered under day 9 and day 8.
Correct. Yeah. If you have any specific question, you can ask. There is no problem.
Okay, no problem. Just want to know. Okay.
Yeah. All right, guys. So let's stop for the day here now. Thank you very much. Now this is a Sunday evening or Sunday morning maybe for you guys. All right.
Yeah, thank you. Thank you very much. It's very interesting and nice learning.
Okay, guys. Thank you.
Thank
Keep
you, Ramesh.
learning,
Thank
One
you.
more
learning and enjoy. Take
and
care
one
of
more.
yourself, guys.
We are
Take your
missing
health.
your classes on Saturday.
Yeah, thank you.